Good morning, everyone. So, in today's class, we are going to learn another topic, that is polarization. Okay, new topic, that is polarization. What is this polarization first? As we know, light consists of electric and magnetic field waves, right? What I am saying, as light wave consists of electric field and magnetic field waves. So, if we are restricting the vibrations of transverse wave in particular direction, that is particularly electric field wave in particular direction, then that phenomena is nothing but polarization. So see here, I am writing the definition. The phenomena of restricting the phenomena of restricting the vibrations of transverse wave in a particular direction. The phenomena of restricting the vibrations of transverse wave in particular direction. This is called polarization. Next now, what is polarization of light? As I told before, okay. So again, I am giving you definition. Polarization of light. Polarization of light. So phenomena of restricting the vibrations of light in a particular plane. In a particular plane. In a particular plane. So as I told before, which component is responsible? Electric component of light. So electric component of light is mainly responsible for optical effects. Is mainly responsible for optical effects. Now, next is plane polarized wave. These definitions are very useful because you should understand everything. So, see, this is another definition, that is plane polarized wave. So, what is this plane polarized wave? When all the vibrations of light when all the vibrations of light wave are in a single plane which contains the direction of propagation of wave. When all the vibrations of light wave are in single plane which contains the direction of propagation of wave, the wave is said to be plane polarized. The wave is said to be plane polarized wave. Which one is unpolarized light? So sun and bulb is unpolarized light. Unpolarized light is example is what? Sun or bulb. It is unpolarized. There is no restriction. है ना? We have not restricted light to travel in one particular plane. Understood? Okay, next. Now Malus law. What is this Malus law? Let's see. The intensity I of the light the intensity I of the light transmitted by the analyzer is directly proportional is directly proportional to the square of the cosine of angle to the square of cosine of angle between the transmission axis of the analyzer and the polarizer. And the polarizer. So intensity I of the light transmitted by the analyzer is directly proportional to square of cosine of angle between the transmission axis of the analyzer and polarizer. So that is I is directly proportional to cos square theta, and I is equal to I naught cos square theta. This is what your Malus law is. if I want to find intensity of polarized light is equal to I naught by 2. I naught by 2. So here I am giving you intensity is proportional to amplitude square. We have learned this, and therefore I by I naught is equal to E naught cos square theta divided by E naught square. That is equal to cos square theta, and therefore you are getting I is equal to I naught cos square theta. Now average value of cos square theta, how much you are getting? Average value of cos square theta. So cos square theta is equal to 1 by 2 pi integration 0 to 2 pi cos square theta d theta, and that is equal to 1 by 2 pi integration 0 to 2 pi 1 plus cos 2 theta by 2, into d theta. If you will solve this, you are getting how much? 1 by 2, and therefore I polarized is equal to how much? I naught by 2. Understand? This is what Malus law. Note down. Next, Brewster's law. Next one is what? Brewster's law. The tangent of angle of polarization. What is the law? C. Tangent of angle of polarization tangent of angle of polarization is equal to refractive index of medium is equal to refractive index of medium. But what is angle of polarization, sir? This is what most important question. Okay, what is angle of polarization? So wait for that. Let me draw the diagram first. This is the interface, and now this is incident light, we can say. This is 90°. Okay. So this is medium 1, that is refractive index mu1, and this is medium 2, whose refractive index is mu2. Okay. So first I will tell you what is angle of polarization. Angle of polarization in bracket theta of P. Angle of polarization. So angle at which, in a simple language, angle at which reflected and refracted rays are mutually perpendicular. Angle at which reflected and refracted ray are mutually perpendicular. Right? And now let's see here in this diagram, using Snell's law at point O. This is point O, suppose. So see, at point O, using Snell's law. Using Snell's law. We know Snell's law. What is that? Mu1 sine of theta p is equal to mu2 into sine of theta 2. Now this theta 2 is what? This theta 2 is how much you are getting? This is the 90, hai na? Yes. So shall I write there 90 minus theta p? Yes. So this is equal to mu2 into sine of 90 minus theta p. This is mu1 sine of theta p. So therefore, mu1 sine of theta p is equal to mu2 cos of theta p, and therefore mu2 by mu1 is equal to sine of theta p divided by cos of theta p, which is equal to tan of theta p. And hence what we are getting now, tan of theta p is equal to mu2 by mu1, right? Okay, tan of theta p is equal to mu2 by mu1. Clear? Yes, this is what your Brewster's law is. So let's stop here for today. Bye.